Lesson 8.5 is factoring polynomials that are in the form x squared plus bx plus c. And you have to understand that this is always going to be a 1x squared plus b and c are just real numbers. So they're showing you, it says you know that if you have x plus 3 times x plus 4, you can actually FOIL this, and we know that we're going to get an x squared, and then we're going to get a 3x and a 4x, so really that's 4 plus 3x, and then a 3 times 4 is going to give us 12. So what we're going to do is we're going to unfoil them or factor them. And this goes along with a game that I had us play a little bit earlier. We're looking for two numbers whose product is the c value and whose sum is the b value. And that's basically all this is saying right here. So I'm going to go ahead and put my parentheses, my quantities, and I know to get an x squared I have to have an x times an x. And now I want factors of 7 who will add to 8. Well, that's easy. That's a 7 and a 1. And this is what I call the smiley method. We're really going to use the smiley face method more when we have a coefficient that's not a 1 here. But if I look at this, this is 7x, 1x, that gives me 8x, and 7 times 1 is 7. So let's do this now. We have a negative b term. I'm still going to put b and b for my b squared. I want factors of 10 that will give me a negative 7. Well, factors of 10 are 1 and 10 and 2 and 5. And to get a negative 7, they both have to be negative. And a negative 2 times a negative 5 is a positive 10, so it does work. Negative 2 plus negative 5 is negative 7. Negative 2 times negative 5 is positive 10. Here's another one. We're going to go z times z, and for 40 I've got more that I can list. It's 1 and 40, 2 and 20, 4 and 10, 5 and 8, and I want them to combine and make a negative 14. If you have a negative for your middle term and a positive for your final term, you have to have two negatives. If this is going to be positive, you always have to have two like signs, and the middle sign is then going to determine whether they're both positive or negative. And to get a 14, I'm going to use a 4 and a 10. Negative 4 times a negative 10 is positive 40. Negative 4z and negative 10z is negative 14z. So let's try another one. I've got tons of these for you. So here we go. We've got x and x for x squared. The only factors of 3 are 1 and 3, or 3 and 1. It's positive with a negative middle term, so they both have to be negative. I'm going to get a t and a t. Factors of 8, or I'm sorry, factors of 12 that differ by 8 are going to be 2 and 6. 2 times 6 is 12, but negative 2 plus negative 6 is negative 8. Let's try this next one. In order for me to get a negative c term, I have to have one positive and one negative factor. So the factors of 20 that differ by 1 are going to be 4 and 5. Well, I want it to be a positive 5 and a negative 4, because this gives me a 5m minus 4m, which is positive 1m, and 5 times negative 4 is negative 20. Let's do this one. I'm going to get a w and a w. Again, I have to have a positive and a negative because I've got a negative final product, and I'm looking for a 6, and that's going to be an 8 and a 2. I want a positive 8 and a negative 2 because I want a positive 6, and this gives me 8w and a negative 2w, and that gives me 6w, and 8 times negative 2 is negative 16. Alright, when we solve them, this is no different than what we did when we had to factor out our greatest common monomial factor, except now we're going to get binomial factors. But the first step is you always set it equal to 0. So it's set to 0, so I'm going to go ahead and factor. I have an m and an m. I have a negative 14, so I have to have a negative and a positive. And again, it doesn't matter if you go negative, positive, positive, negative. To get a 5, I'm going to use a 7 and a 2. I want a negative 7 and a positive 2, because this gives me negative 7, positive 2 is negative 5. Now the next step, just like before, is you're going to set each of these factors equal to 0 and solve. So here I get m equals 7, and here I get m equals negative 2. Let's try it again. Again, it's already set to 0, so I have an x and an x. I'm going to have positives all the way around because I have a positive product and I have a positive sum. So to give me a 24, it's going to be 8 and 3. And sometimes they come to you quickly, sometimes they don't. It doesn't matter as long as you can get them eventually. So I set each factor to 0. And when I solve this, I'll subtract 8. So x equals negative 8. Subtract 3, x equals negative 3. Let's try this one. I have n squared minus 12n plus 27 equals 0. N and n. I have a plus 27 but a minus middle term, so they're both negative. And 9 and 3, when I multiply, give me positive 27 and a negative 12. So now set those to 0. So if I add 9, I get 9. If I add 3, n equals 3. Now here, here it got written down wrong. This is equals. I don't know why that was cut out. So it doesn't matter. It says find the zeros, and I alluded to that before because the zeros are where it crosses the x-axis. So it's what is the x value when y is 0. So I just go x squared minus 5x minus 36 equals 0, and I will factor. So x and x, I have to have a positive and a negative to get the 36, and I need these to differ by 5. So this might take a little bit more time. I know I have a 1 and 36, that doesn't differ by 5. I have a 2 and 18, that doesn't work. 3 and 12 doesn't work. 4 and 9. Okay, 4 and 9 work. And I need a positive 4 and a negative 9 to make this a negative 5, because this is a positive 4x, negative 9x. Now I just set them equal to 0. So in this case, x will equal negative 4, and I'll set this one to 0, and x will equal positive 9. Do the same thing here. Again, that should be an equal sign. So if I do set it equal to 0, 0, I have an x and an x. I have to have a positive and a negative because I have a negative here. So I want factors of 20 that will give me an 8, and that's going to be a 2 and a 10. I need a positive 10 and a negative 2 because I need a positive 8. And I know this seems probably a little silly to you, but I don't want you to skip this step right here. I don't want you just going x equals negative 10 and x equals positive 2, because this is setting you up for further work that you're going to have to do later. So the steps are important. Last one here, I have x. This again is equals and x. I have a positive 24 and a negative 11, so they're both negative, and 8 and 3. And it's almost exactly like problem 14, except I'm going to get the opposite answers. So I get x equals 8 and x equals 3. All right, last one. A community center is building a patio area along two sides of its pool. So we've got the patio here and the patio here. The pool is rectangular with a width of 50 feet and a length of 100 feet. So they've shown that. And the patio area will have the same width on each side. So we're looking at these are both x. Write a polynomial that represents the combined area of the pool and the patio. Okay, so this particular side is x plus 100, and this side is x plus 50. So there's that. However, it says write a polynomial. So I need to go ahead and FOIL this. This is going to give me an x squared. There's 100x and 50x, so plus 150x. And 100 times 5, or I'm sorry, 50 is 5,000. So that's part A. Part B, they're saying, okay, the combined area of the pool should be, the pool and the patio should be 8,400 square feet. So I want to set this equal to 8,400. And now I need to go ahead and solve this. Remember, the first step is to set everything equal to 0. So I have 0 equals x squared plus 150 x, oops, I don't want it to look like it's a power, 150x minus 3,400, and now I need to go ahead and factor that. So I'm going to get an x and an x. I have a negative 3,400, so I know I have to have a positive and a negative, and I have to try to brainstorm some factors of 3,400 that will give me 150. Well, that's going to take me a minute, so let me think about it. All right, they are actually 170 and 20. 170 times 20 is 3,400. I want this to be a positive 150, so I'm going to go positive 170. Whoops. And negative 20. Now I set each of these to 0. So algebraically my answer is negative 170, but that's the value of x, and I cannot have a negative length or width. So I can't use that. Algebraically it works and I would expect to see it, but when you write your final answer, you're going to add the 20 to both sides. So x will equal 20 feet. That's how wide the patio should be. All right, that is it. If you want to go ahead and get started with your assignment, you're welcome to. This is lesson 8.5. And the problems are on page 528 to 530. Problems 4 to 40 even. 44 to 54 even. 59 through 61.